So what's NumPy? If you segregate the words num and pi, num stands for numerical computations and pi obviously stands for Python. So in the previous classes, remember Mihir had told you that Python acts very nicely as a calculator. It does all its addition, subtraction, division operations very easily. So why for numerical computations we need a different kind of package in Python? What exactly does numerical computation mean? So numerical computation includes concepts like matrix multiplication. So why in machine learning are we learning about matrix multiplication? It was a concept introduced in class 11, right? The need is in machine learning, we deal with a large number of data set, be it images, be it ints or floats. So for you guys, the image looks like this. But to the computer, it is in a matrix format. Is everyone till here? Good with me till here? Everyone understanding? That these kind of image data sets to us are images, but to the computer, they are in the form of matrices. So that's why machine learning requires a large amount of numerical computations like matrix multiplication, like differentiation, integration, partial derivatives, some transforms, etc. So NumPy is the foundation of Python scientific stack. So on NumPy depend the other packages, for example, SciPy, Matplotlib, Pandas, Keras, TensorFlow, etc. So these all heavily depend on NumPy and its data structures, which is an n-dimensional array. So let's see in detail what actually is NumPy. It has a powerful n-dimensional array object. So you guys know what an array is? Does anyone know what an array is? Yeah, a collection of similar elements. Similar here means of same data types. And these same data types are stored in contiguous memory locations. So NumPy also has sophisticated broadcasting functions. What are these? We'll see in a minute when we'll be doing our hands-on session. And NumPy is useful for carrying out linear algebra functions for transforms like Fourier and Laplace. And it also has random number capabilities. That is random number generation, normalized random number generation, etc. So again, why NumPy is used in machine learning? As in, why NumPy array is used in machine learning? Why cannot the same task be accomplished with a list? Can anyone guess why not we are using list, but we are needing a different package that has arrays? Am I going too fast, too slow? Please let me know. I would like some answers in the chat box, people. Not sure. Can you see the list is made up of heterogeneous data elements? A is a character, 6 over here. Let me go over. So 6 over here is an int, so is 7, 9.0 is a float, and this one is a string. But over here, this array is composed of all floats. It can be composed of all ints, all strings, all characters only. So a list is flexible, as you can see, but an array is tightly bound to its data type. So a list has many data type objects, while an array is homogeneous. So list occupies more memory, while an array occupies less memory. Why is that so? Because in a list, each element of the list takes additional space to store the pointers, because these elements are not stored in contiguous memory locations. So to search them, space should be allotted to this character as well as to the pointer. To store 6, a space of 4 bytes should be allotted as well as space to its pointer. But this is not the case with an array. Every element just needs, for example, floats need just 8 bytes. And only one pointer, one header will be needed for this whole array, pointing to the first element of this array. So an array takes up less memory and is more efficient for sorting and searching. So for these two reasons, a NumPy array is used over the list which Python provides. So see over here diagrammatically. Suppose all of these elements are floats. So each element will take up how many? 8 bytes of memory, right? But over here you can see that all of these elements are taking pointers as well as 8 bytes of memory. So have I made myself clear with this diagram over here? That a list for the same type of objects takes large amount of memory compared to an array. Yeah, Santosh. So should I go over again? Okay, so an array over here is composed of homogeneous data types. Homogeneous means they are of the same type. For example, over here, all of the elements are floats. They can all be ints or even strings, right? Okay. So an array takes less memory. Why less memory? Because an array just needs one header pointing to the first element. All of these elements are stored in contiguous memory locations like this. So the first element is here, the second is here, the third is next to it. They are all neighbors and so on, right? So just one header is needed, and to each, and suppose if you have to go to the next element, you'll just add 8 bytes to the address of this header, because as soon as you add 8 bytes, that will be the address of the second element, right? But this is not the case with a list. List has objects that are stored at different locations in the memory, in the RAM. Why to the last element, Sudipto? If you know the length of the array, you can just travel, adding n-1 into 8 to your header, and you'll reach the last element. Is it okay now? Getting everyone? Suppose to reach the second element, you are doing what? 2 minus 1 into 8. And adding this to the header's address over here. Okay. So everyone is clear? Yeah. So over here, as you can see, there are different headers for each element of the list, which is 0x310718. Then the next element is at 748. The other element has gone upwards, 730. So all of these list elements need different headers, different pointers, along with the space given to that element. Is everyone with me? Yeah, so these are the headers. These are the pointers. Yeah. So we have seen that list takes more space, more memory than a NumPy array, right? So an array is taking up less memory. Is this feasible? Is this what we need in machine learning? Do we need less memory or do we need more memory? Do we need a data structure that occupies less memory? Yes, because in machine learning, the data set itself is so much humongous, it's so large that to perform operations on it, we would need a data structure that occupies less memory. Yeah, everyone? And in addition, we would need a data structure that takes less time to compute. Yeah. So over here, I have a list that I'm forming using the range function. And it's taking 5.07 microseconds. Now this list has what? Can anyone tell me what this list is composed of, as you can see, and have learned about the range function? So this L has how many elements? Am I audible to everyone? Deepto says he cannot hear me. Yeah. So I'm asking, this L over here is a list that is getting composed of this range function starting from 1, going till 1000 and taking steps of 4. So can anyone tell me what this list will look like? Yeah, right. 159 and so on till 1000. Will 1000 be included or excluded? Yeah, excluded, right. So the start element is included in the list, but the stop element is excluded, while 4 is the step. Okay, so everyone with me till here. So this is taking 5.07 microseconds to get formed. And it's also taking a large number of space, right? But an array that is made up of Numpy, so I've imported the Numpy package over here, and using arrange function made the same list or made the same array. Now it's an array because we are using NumPy. So it also has the same elements, which is 1, 5, 9, etc. But the time taken over here is just 1.71 microseconds. So a NumPy array is taking up less memory and also taking less time for its computation. So isn't this a good idea to perform all our machine learning calculations using this package instead of list in Python that it provides? Yeah. So this is why we'll be learning about NumPy. So everyone, these are the cells over here that you can see. This is a cell. Now a cell can be a code cell. So by default, this is a code cell. If you typed in 2 plus 3 and press this cell, which is run, this will give you the answer as 5. If you similarly did 8 divided by 2 and press this run cell, it will give you the answer as 4.0. So it's running as a code cell over here. Now, what if I want to write something? For example, I just now asked, what does Jupyter stand for? So I can go in here to heading. So there are 6 types of headings in HTML. The first one is H1, H2, H3, so on till H6. So one hash means this is the heading number 1. So to my heading number 1, I'm saying Jupyter or Jupyter. So what does this stand for? Now I have to write a paragraph, so I'll choose the option as Markdown. So for me, JU means, as far as I know, JU stands for Julia. Julia used to be a programming language used for data analysis. PY, we all know, stands for Python. And R is another language in which, the R language, in which data analysis is done, and also machine learning these days. So combining all these languages, which we can use in Jupyter notebooks. Right now, as you can see, we used Python 3 as our notebook, but we can use the R notebook as well and Julia notebook as well. That's why this thing was given the name as Jupyter notebook. So guys, if you want to delete one cell, how you have saved that? Save what, Santosh? It's dynamic. It gets saved at every checkpoint. Or if you want to do it manually, you can press the save and checkpoint button. Okay, practice. Go over to this untitled thing and change the name. And click on rename. So everyone try this out. If you want a new cell, just click on this insert cell below button and type in, suppose 10 into 2. If you want to run your cell, just press this run button over here. Everyone trying this out? Looks interesting. A nice interface for terminal. Okay, so what if you want to delete one cell? Simply go to the scissors over here that has the option cut selected cells and your cell will go away. Add a new cell, and because you are computing so much, you are writing on the fly. What about shortcuts? So if I did 8 raised to the power 2 and I want the result. So will I go to this run command again and again? No, I'll use a shortcut which is shift enter and I have my answer. So control enter would have given you the answer as well, but not taken you to a new cell. So suppose 5 into 5 into 5 and I press control enter, it's just giving you the answer, but it's not drawing a new cell for you. Instead, if I would have done shift enter, I would have gotten a new cell as well as the answer. So everyone try this out, control enter and shift enter to run your cells. So with this type of markdown over here, we can have multiple headings. Like I can write Jupyter like this as well. And so on till heading number 6. So one hash means that this is H1 and you have chosen your cell as a markdown or a heading cell. This won't work if you have the option code selected over here. This won't work. But only if you have markdown as your option or heading as your option, this thing will work. What if you want something in italics? So just put in one asterisk, write in italics and the other asterisk and press shift enter. So this thing got printed in italics. So these are some of the ways in which you can write comments, headings in your notebook so that your code looks a little neat and clean and readable. Yeah, Shift and Enter will make a new cell as well as run the cell, and Control and Enter will only run the cell and not make a new cell. Right, Piyush? So everyone tried and tested with Jupyter Notebook? Is everyone now familiar to work with it? Should we move to a starter template now? Okay. So if such a warning crops up, like press the save and checkpoint button and then close your notebook. So we are over to our starter notebook. Over to our Numpy again. So you all know that Numpy is the scientific package for numerical computation, and it has an n-dimensional array as its data structure for performing these type of calculations. So guys, in class 11 and 12, you must have gotten familiar with concepts like vectors, matrices, right? So can anyone tell me what a vector is? We'll do a quick refresher because these are the things that we'll be working with. Can anyone tell me what is a vector? Vibha, not in terms of physics, but in terms of mathematics. You're right, very right in terms of physics. Santosh is saying it's an array. We'll implement a vector using a NumPy array. But what is a vector? So vector is just a collection of elements, right? Be it ints or be it floats. So over here you can see a one-dimensional array is known as vector. One-dimensional means it has all the elements in just one row. And vice versa, you can have all the elements in just one column. Remember everyone, you can either have elements in one row, which is a row vector, or you can have all your elements in one column, which is a column vector. And you can implement both of these vectors in NumPy using the NumPy's one-dimensional array. Similarly, a matrix is what? It has both rows and columns. So matrix can be implemented in Python using the NumPy package and thereby using its two-dimensional array. Everyone getting this? Okay. So what about this matrix? How many number of rows are here and how many number of columns are here? You can all see it in your respective starter notebooks as well. And tell me the number of rows and number of columns. Exactly. So 3 into 3, yeah, both are 3, right, Adha? So 3 into 3 is what? The dimension of this matrix. In terms of NumPy, we say 3 comma 3 is the shape of this two-dimensional array. Is everyone getting this? Okay. So now what if I have this matrix and I have a similar 3 by 3 matrix and another matrix, and I'm storing all of these stacked over each other. Vertically stacked these matrices are, and each are having a dimension of 3 into 3. So in mathematical terms, it is known as a third order tensor, and in NumPy it's implemented using a three-dimensional array. So number of rows in each matrix is 3, number of columns in each matrix is 3, and there are 3 such elements. There are 3 such matrices. So this is a third order tensor. And can anyone tell me what its dimension will be? The number of rows are 3, number of columns are 3, and number of such matrices are 3. Right, Sudeep? So it's 3 cross 3 cross 3. So this is how an n-dimensional array can be implemented in Python, or an n-dimensional tensor in mathematical term can be implemented using an n-dimensional array in Numpy. Okay, so let's move ahead and see how can we form a Numpy array using a list. So the first statement that I have given you all is to import Numpy, and since Numpy is a tedious 5-letter word, I have shortened it, given it an alias using the keyword as is a keyword used to give aliases. So import numpy, and we'll be using this numpy as np. Okay, so this is what I mean by importing numpy. You all know that numpy.py will be a file. And I have also given you all a list consisting of 9 elements, which are 1, 2, 3 till 9. So now let's form a numpy array using this list. So I'm storing my numpy array in a variable known as a, and using this numpy method, which is np dot array. So inside this method, I'll be passing my list, which is L, and then let's print it out what A has. So A is now a numpy array, and it has the same elements that our list is having. It just converted itself from a list to an array using the numpy package. So everyone try this and let me know if you are getting the similar result. Has everyone formed the numpy array A with the list L? Good, great going, guys. Okay, so now what if you want to know the shape of a numpy array? Remember, the shape of a numpy array is equivalent to the dimension of that particular vector, matrix, or tensor. So you people, we as well, I as well, so we don't have this numpy.py with us. But you all must be curious to know what all functions that this numpy file has. So the most critical aspect of this is going to the numpy documentation, wherein you can find all the methods. So I would prefer numpy.org to look for all my numpy functions. And click on the latest one. And if you type in this search box shape, you'll get to know how we use numpy.shape. So let's use it over here. So to have the shape of a numpy array, just pass in that numpy array and do a dot shape. Shape over here is not a method because we are not having these parentheses. It's just the attribute of the array. It's the property of the array. and press in Control Enter. And you'll get the shape as 9 because there are just 9 elements in one particular row. So everyone getting 9 as their answer as the shape of this array? If you're stuck with what methods or attributes to use, just go to the Numpy documentation, which is available on numpy.org, and do a quick search and you'll get how to use this. Okay, guys. So now what if you have to reshape your Numpy array? You have 9 elements over here. So preferably if you want to reshape it into a number of rows which are 3 and number of columns which are 3, how to do that? So let's search in our Numpy documentation about reshape. And in a similar manner, it's doing numpy.reshape, that is on the same array. We are having this reshape. Let's see if it's a function or an attribute. So it's a function because it has the parenthesis and we are giving the shape. Okay. So let's analyze this further if there is an example available. So yeah, here's the example. On this numpy array, we are doing a reshape and passing in our shape as a tuple 3, 2. So let's do the same thing with our numpy array as well. So I have to reshape it to 3 cross 3. So I'll do a dot reshape, give the parenthesis and give my shape, my dimensions in another tuple. So everyone knows that for tuple we use parenthesis. So in parenthesis, I'll be giving 3, 3 as my shape that I want for this numpy array. And I'll be pressing Control Enter. And my array now becomes of 3 cross 3. It has 3 rows and 3 columns. And the number of elements are still the same, which is 9. So guys, do let me know if you are getting it. If you are done with it, type in done. So is everyone getting what we are doing? We are forming an array using a list. Then we are taking out its shape, that it's indeed a one-dimensional array. And then we are converting that one-dimensional array into a two-dimensional one and using our shape as 3 rows, 3 columns. So this is how powerful NumPy library is. And you can do all your shaping and reshaping and formation of a NumPy array in it. All of the matrix calculations can be done using NumPy. So let me know if you all have tried this and gone through this documentation over here and agree with me that reshape indeed is a method and this is how we can reshape an array. Please type in done. Because Santosh, 3 cross 3, 3 into 3 is just 9. You can see that each row is having 3 elements over here. There are 3 rows, okay? And each row is having 3 columns. So you're having 3 cross 3, that is 9 elements. So what about a big array? So first we'll see how many, suppose over here, if your one-dimensional array had supports 121 elements, then using factorization, you can group it into 11 cross 11. Agree with me? Like we did with 9. And in a similar manner, if you had suppose 48 elements, you can either form a two-dimensional array with 24 cross 2 or a shape of like 12 cross 4, so that the number of elements also remain intact. So is there no, you'll have to do it manually. You'll have to think about it. This is why human intervention comes in. And using this, we can either expand an image or compress it using these dimensions, which you'll learn later when Mihir will be taking over. Okay, so everyone done with this? So now what if you are curious to know what data types are arrays having? So anyone go to the documentation, type in data type in the search box and let me know how may I retrieve the data type of this particular array using a method, using an attribute, whatever you find on the documentation. So go to your documentation and in the quick search, just type in data types. And you'll see something like D-type objects over here. Yeah, great. So what we can do is simply on this array, we can type in D-type and press Control Enter, which is an attribute, and you'll get that it's composed all of ints, and those ints are taking 32 bits each. So again, data type, for data type, we have an attribute which is D-type, and on A, this data type is giving us a result of int 32. So has everyone understood this? Okay, so what if I want an array from this list, which was L, but now I don't want all integers, I want floats. So I'll be passing in D type equals to float 64, because floats take 64 bits each, that is 8 bytes, while ints take 32 bits each, or 4 bytes. And then I'll be checking my array. So from this list of integers, I've gotten an array of floats, which is 1.0, 2.0, 3.0, and so on. So this is how we can declare data types explicitly. Yeah, so everyone is getting this? Or in a similar manner, I could have a list of floats, which is 1.1. All the information will be lost. So let it be 1.1, 2.0, 3.0. And let us be making a list out of it, sorry, an array out of it, using np.array, passing in our list, which is list. Let me give it a different name. Let it be li, and a d type as int 32. And let's see what we are getting in our array B. So we are getting 1, 2, 3. Okay. So this is how you can convert a list of floats into an array of ints and vice versa using the dtype attribute in Numpy in np.array function. Okay guys, so let's go on to some other methods for array creation. So once you reach over here, for a 64-bit machine, yes, they are fixed. Otherwise, you can also use float underscore if you don't know the configuration of your machine. So it will take up 8 bytes or 4 bytes accordingly. And similarly for int underscore. In the solution notebook, you guys can see what all data types are used in NumPy. So you can see an int underscore over here, a float underscore over here, an str underscore, and so on. So once you reach numpy.arrange, just highlight this and click on this plus over here. You'll get a cell. And suppose we want a range of values starting from 0 till 10. So we want 0 to 10 as our array elements. So you can print that out not by tediously writing what if you want 0 to 100 as your elements. So you'll not go on writing 0, 1, 2, 3 and forming a list out of it first and then converting it into an array. You can very easily achieve that same result using np.arrange function. So be a little cautious about this. This is not ARR, but ARANGE, the spelling. And you can pass in 10 over here. So it starts counting from 0 and it will end till 9. So you'll get an array which has elements 0 to 9. And similarly for 100, if you put in 100 here, you'll get an array that has elements from 0 to 99. So if you want an array starting from 1 and you want to go all over to 100, so include 101 and you'll be getting 1 till 100 as your elements. So as everyone understood this arrange function, and similarly if you want your elements to have a step of 5, you can do so as well. So it will be 1 plus 5, then 6 plus 5 and so on. Okay, so next we'll be trying numpy.linspace. So anyone go to the documentation and let me know what this linspace is doing. Just give me a guess that why are we using this function for array creation and how is it helpful? Rather give me an example of using this. So let me also do it with you guys, linspace. Restriction per page execution. I'm not getting what you're talking about. It's not printing the values. Santosh, please type in what are you writing over there so that I can help you. np.arranged 1, 2. So let me run the same thing on my notebook over here, 1, 20, and it's printing for me. So make sure that you have import numpy as np running, and you have the correct spelling of arrange over here, which you are writing it correctly, I believe. Yeah, great. So moving on to this numpy.linspace, go to the documentation and give me an idea of why this function is used, how this is used. I want you all to be reading the documentation yourself and coming out with insights about the methods of NumPy. So this is why I'm redirecting you all to NumPy documentation. Yeah, so to divide the range in pieces, right, Sudipto? So let's try an example over here. So again, my array has the start and the stop range. First, the name of the method. Then let me do 0 and my stop is 2. And I'm dividing this into 10 equal pieces. So let's see what we are getting as a result. So this is 0.22, 0.44. Let's do a 5 over here. And we are getting 0.0, 0.5, 1, 1.5 and 2.0. So if you guys have gone through that session in which you were to calculate the slope of the line that you were being asked, and you didn't have enough points, like you just had 1 point, which was 0, 2, and then you had to calculate the slope. So to calculate the slope, you need at least 2 points. So this is how you can do. You can cut your numbers into chunks, into pieces, and then see that for that value of x, what are you getting your y as, and compute your slope. So just a vague example of how you can use linspace and why is it useful. It's useful for function estimation, interpolation, and things like that. So let's see another method of creation of an array wherein all the elements are zeros. So this kind of an array is known as zero initialized array. And the function is np.zeros. zeroes. And you can pass in the dimension of this array over here. That is, you need a 3, 3 array, 3, 2 array that has all elements as zeros. So let's verify if I'm saying the right thing. So you can see np.zeros is taking 2 rows, 3 columns and giving me an array which has 6 elements in total, 2 rows, 3 columns, all having zeros as their elements. So it's zeros as the function, and I'll pass in a tuple with number of rows and number of columns. So guys, have you all tried arrange, linspace and zero initialized methods of creation of an array? Everyone, I want a yes from everyone. If not, then I'm happy to wait or answer your queries. Great, Vibha. Great, Piyush. Great, Udhav. Okay, so we are all in sync. So here is a quiz for you all to find the one initialized array creation method and also to find multiple diagonal values method. So you guys need to submit your notebook on your course page with these methods, and we'll see how we can form an array which has constant diagonal values. So we have the Numpy array creation methods over here. So can anyone tell me how to form an array which has constant diagonal values? That is 1, 1, 1 in diagonal, or 2, 2, 2 in diagonal, and so on. That's not true. Yeah, that is for one initialized, Sudipto, np.I. Numpy.diagonal, the whole of the method. Let's try np.diagonal and just pass in one value, which is 1. Sorry, this is for multiple diagonal values. So 1, 2, 3. It's wrong. Okay, we are not passing in a tuple. Yes, so this is for multiple diagonal values. Let me change the quiz then. And your quiz is to find the method for constant diagonal values. All of you, please do this similar changes. You have to find the function which has all ones in the diagonals, all twos in the diagonals, and so on. And I've given you the answer for multiple diagonal values. It's also there in the solutions notebook. Or you can say 1, 2, 3 in diagonal, and also like 1, 2, 3, 4 in diagonal, and so on. So this is the method via which we can create arrays of different nature for our use. So has everyone tried this multiple diagonal values? Okay, great guys. So till now we have seen what an array is, what its shape is, how we can reshape it, how we can create it using these different functions. But now we come across a concept which is axes. So in a NumPy array, which can be one-dimensional, two-dimensional, three-dimensional, and so on, the axis can either be none, the axis can either be 1, or the axis can either be 0. So what does this all mean? We'll see in a while. So in the picture that is given to you guys, I have how many elements are there? First tell me in this picture. And what's the shape of this matrix? Yes, Sudipto. Are there 12 or are there 15? Yeah, right, 15. And the shape of this matrix is 3 cross 5. Great. So first I formulated this same thing over here. My array is having elements starting from 0 till 14 and I've reshaped it 3 cross 5. Okay. So now using axis equals to none. How is this axis useful? So for all of these elements, we can compute sum. So we can say a dot sum, and I can pass in axis equals to none. And when I'll do control enter, I'm getting, sorry, I didn't run this. I'm sorry about that. So I'm first running this cell and then this cell. So I'm getting the sum as 105. It did what? It added all the elements 0 plus 1 plus 2 plus 3 till 14. And it gave me the result as 105. Similarly, if I wanted to find out the maximum element of this matrix with axis equals to none, I can do an a dot max axis equals to none. I'll get that as 14. Sure, Santosh, okay. So guys, over here, the axis is none in this matrix. So using this axis equals to none, I can compute the sum of this array using a dot sum. And to this function, I'm passing axis equals to none. And what it's doing is computing the sum of all of these elements and giving me the result as 105. So has everyone tried this? Okay, great. So what is the answer if you ran a dot min? Just a dot min. You're not passing an axis equals to none. What's your answer, guys? 0, exactly. So axis equals to none is by default. You don't have to mention it explicitly. Axis equals to none is by default. So a dot min will give you 0. And similarly, a dot sum, if we ran this without writing axis equals to none, will also give the result as 105. Are you all with me till here? What's the work of min? Min is for minimum. What is the minimum element in this particular matrix? What is the maximum value? For example, in pixels of an image, what is the minimum and maximum value? Okay guys, so now axis equals to 1. So this will give me the sum of elements row wise. So if I did a dot sum and passed in axis equals to 1, what do you guys think will be the result? From this picture, can you make out what the result will be? A dot sum axis equals to 1 is giving me the first element as 10. So it has done what? It has added these elements in the first row. 0 plus 1 plus 2 plus 3 plus 4. And similarly 5 plus 6 plus 7 plus 8 plus 9. And for this also 10 till 14. It has added all these row wise and given me the answer as 10, 35, 60. Yes, sum of each row. And similarly, we can do this column wise as well. A dot sum axis equals to 0, and you'll get the answer as 15, 18, 21, 24, 27 for each column. Axis has 3 values, Santosh, none, 1 and 0. Row wise, column wise, and no axis. So over here it's adding 0 plus 5 plus 10, 1 plus 6 plus 11, and so on, and getting me the sum of all elements column wise. So please type in done if you all have tried this, and you can also try a dot max with axis equals to 0 and 1, and similarly a dot min. And you'll get the maximum number of elements row wise and the the highest element column wise. Done. Okay, great. So now from a matrix, you have to derive only some of the elements at a particular instance of time. If this matrix is having all my elements from 0 to 14 and I only want to derive elements from 0 to 9, or this one 11 to 14 only, this is of my interest. So how may I do that? I want only the first row over here, the second row over here, and all the columns in these two rows. And remember, Numpy starts to index its elements from the 0th index. So this 0 has occupied an index of 0, 1 has an index of 1, and so on. My 4 has an index of 4. So this whole row has an index of 0, this whole row has an index of 1, and my last row has an index of 2. So I'll do some slicing over here. I want all my columns. I want the elements from all my columns. So for that, I'm using colon. It's always row, comma, number of rows, comma, number of columns. I want all my columns. So I've just put in a colon over here, but I want my first row, my second row, but not my third row. So I'm starting with 0 and ending with 2 because I don't want this last row with the index 2. I just want 0 and I want the first row and all elements of it, all columns of it. So when I'm doing control enter, I'm indeed getting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So guys, go ahead and tell me how may I get these elements 11, 12, 13 and 14. Type in the chat boxes what you think. Some different method on how to achieve it. Instead of colon over here, I could also have written 0 to 6 and I would have gotten the same result, that is all columns starting from 0 till 5. Or simply a colon would do. Yeah, right. So it's A. I want the last row which has this index of 2, comma. I want the elements starting from 1 till 4. So 1 is to 5. Or simply you can leave this, that is 1 and colon, and get the same result. You could also have omitted this 0 over here. So it's just colon 2 comma colon and you would be getting 0 to 9 as your answer. So colon just means that if you're not giving it any value before, suppose, and you're giving it a value after, so this means that everything from starting, from the start index till the stop index that you have mentioned, if you're not giving any value before colon. And similarly, if you have a value before colon but no value after the colon, you are saying that take into account every value starting from the index 1 till the last index. And if you are omitting these two integers also, you mean that take into account every value from the start till the end. So has everyone tried this? Shall we move ahead? Is everyone able to see and hear me clearly? See my screen and hear my voice? Okay, so Sudipto, there must be a problem with your internet connection. And similarly, if you want to get these elements, that is 2, 3, 7 and 8, we can start from the third column, which means from 2 till 4, and from over here also from 0 till 2. So it's 2 is to 3 is not the correct thing which is shown in the picture. It's 2 is to 4 for the columns. You could also have removed 0 from here, colon 2 comma 2 colon 4 would have given you the result as well. So I think everyone has understood how to retrieve elements or a group of elements from a matrix using indexing and slicing. So should I move ahead? Santosh, any question? Santosh, Sudipto, Vibha, Uddhav, Piyush, any questions? Great. So now we are coming to this most important topic of broadcasting. Yeah, index always starts from zero, be it C programming language or Python, or even the module Numpy. So let's go over broadcasting. So if I would have given you uh, and typing on the chat window, if I had, okay, so this is not working. So let me take you to the picture as only. So if in reality you had a matrix which has these elements 0, 1, 2, 3, 4, and you would have to add 10 to it, would it be possible? Would it be possible to add 10 to each element? Because 10 is a scalar while 0 to 4 is a one-dimensional array. If you wanted 10 to be added to each of your element, you should also have a one-dimensional array of the same length as your array A, and then this 10 could be added to each of your elements. Agree with me? The shape, the dimension of a one-dimensional or a two-dimensional or a three-dimensional arrays should be same if you want to perform addition, subtraction, multiplication, and things like that. But NumPy makes it easy. What it does is you can add this scalar to this vector, a one-dimensional array. Why? Because this scalar broadcasts itself. This has a less dimension, this scalar. So it broadcasts itself in accordance with the larger array, and then you can perform addition, subtraction, multiplication, division, etc. So it is broadcasting itself into the one-dimensional array of the same length as A, and then it's performing A plus 10 and getting you the result C as 10, 11, because 1 plus 10 is 11, 2 plus 10 is 12, 3 plus 10 is 13, and 4 plus 10 is 14. If you would have tried this A plus 10 in your class 11, you would have gotten 0 marks and would have written this answer C. You would have gotten 0 marks because you cannot add a scalar to an array like this. But in NumPy it's possible using the term broadcasting. So see over here, I have my A, which is np.arrange, which is 0 to 4, and I have my B, which has these 5 elements, all 10. So to show you guys, let me show you A. So it's 0, 1, 2, 3, 4, and B also is 10, 10, 10, 10. Now if I performed A plus B, the result would have been 10, 11, 12, 13, 14. But NumPy makes it more easier. If you will just type in B equals to 10 and perform A plus B, it will be giving you the same result. So B is broadcasting itself in accordance with the larger array, which is A. So is this clear to everyone? Is broadcasting clear to everyone? Okay, great. So similarly, if you had a matrix over here with 3 columns, 2 rows, and just a column vector over here with 3 rows, 1 column. Now this column, okay, let me talk in terms of Numpy. So this is a 2-dimensional array, and this is a 1-dimensional array. So 1-dimensional array has lesser dimensions. So this will broadcast itself in accordance with the larger dimensional array and then perform this arithmetic calculation over here, be it plus, minus, multiplication, etc., and give you the result. So over here I have my A, which I shall show you guys, and also my B, what it looks like. So my A is 0, 1, 2, 3, 4, 5, and my B is 10, 20, 30, a column vector. And if I perform A plus B, which cannot be possible until and unless the dimensions of both the matrix are same, but here it can be achieved, and this is my result. So please everyone try it and let me know if you have any doubts with broadcasting. I'll be waiting 2 minutes for this and then move on to Matplotlib. So if any doubts related to NumPy, broadcasting, indexing, slicing, please be ready to ask right now. Which one, Santosh? This one, addition of a scalar to a 1-dimensional array. Yeah, so this scalar is broadcasting itself in a shape that resembles the larger array. Okay. So try out both. So Santosh, you're using np.array. So in your array, there is just one element 5. But if you would have used np.arrange 5, you would have gotten 5 elements, 0, 2, 4, 0, 1, 2, 3, 4. So Deepto, that will be one initialized, na? np.I, all ones in the diagonals, all ones in the whole matrix. But here we are concentrating on diagonal values only. And that's a homework for you. So guys, let's move on to data visualization using Matplotlib. So Matplotlib is another library, another module of Python that enables one to plot graphs based on the data. So plotting graphs is important because you want to analyze your data. You want to see what pattern your data is following and what are the outliers, if any, present in your data. So when you visualize a thing, that becomes more clearer. So these are the different plots which are used. So you have a line plot, scatter plot, you have histograms, bar graphs, box plots, etc., that are important for statistical programming as well as to see any patterns that are emerging from your data. So to import matplotlib, I just want to import one file from matplotlib, which is pyplot for our plotting purposes. So I have imported matplotlib.pyplot as plt, given it an alias of plt over here. So has everyone gotten transition to matplotlib now with me? Why we are visualizing data? Because this is important to see patterns in our data, to identify any outliers, and for statistical importance also, for getting the skewness of our data, if it's negatively skewed, positively skewed, etc. So everyone say yes if you're with me, if you're getting this. Okay. So we now will be plotting line plots. So line plots are useful when you have time series. Suppose you have stocks over a period of time, the number of stocks for every month, for every quarter of the year, suppose. So when you're doing a time series analysis and you want a continuous data fluctuation, so you are using line plots there. You want to see how with time, how in 2000, in 2001, 2002, how these stocks, are they rising up or are they falling down? So for these kind of computations as well as for weather forecasting, you need line plots. So for this particular example, I have X with me, which is np.arrange5, which is nothing but 0, 1, 2, 3, 4. Next, I have Y with me, which is randomized numbers. So let's first see what is this X and what is this Y. So Y will take normalized values from 0 to 5, not the integer values, but these normalized values. Okay, so we are plotting these X and Y values using simple PLT dot plot to plot a line graph and passing X comma Y. And you will encounter a matrix like this, MATLAB plot lines dot line 2D. If you want to avoid this, then also write PLT dot show, which is a method. So we are passing in the parentheses and just press in Control Enter. And you get a line graph. So is everyone getting this? It's having its own y-axis, x-axis, and it's plotting x with respect to y in a straight line manner. Okay. So what if you want lines in a dashed format? You want the same line graph. So you want plt.plot. You want the same x and y values, but you want your graph to be dashed. So you'll use this within single quotes dash dash. And then again plt.show to avoid the extra information, and then press Control Enter. And I'll get the same line graph, but with dashes over here. You can also change the color of this plot using COLOR equals to, suppose, green, or simply G. Writing in green or G would mean the same. So this is how you can customize your respective plots as well. So is everyone trying this out? Let me know if you have any queries, or type in done if you are done with plotting this. Okay, so seems like everyone is doing great. Now let's move on to plotting subplots for a line graph. That is, you want two line graphs in the same plot. So first, first of all, if you want two line plots side by side to analyze what kind of a data. So suppose if you have stock prices from 2000 till 2005, and a different data set you have stock prices from 2010 till 2015, and you want to analyze for the same company how they were doing in those 5-year gaps, and you want to plot them side by side. So for that, first is you'll choose that plot size. So don't pay attention to this. You'll choose the plot size, which is fixed size equals to 15, 10. So you want a length of 15 and a height of 10 for each of those two line plots. And you are allotting this fixed size using this function plt, which is matplotlib.pyplot, which we have aliased as plt. plt.figure fixed size equals to 15, 10, and storing this in this variable fig. So now you have the dimensions of the plots of both the line plots, which is 15, 10. Now for the first plot, you need an axis because you are drawing the first plot as a subplot. So you'll do what? You'll say that to this fig variable, I want a plot of this size 15, 10, and to this size, I'm drawing my first subplot. So using the function add underscore subplot. And this needs a 3-digit number in which 0 doesn't come up. So I have taken arbitrarily as 231, my 3-digit number, my first 3-digit number, and 232 as my second 3-digit number for the subplot. Next, I'll be giving the title to this subplot, which is using this method, which is set underscore title. And then I'm drawing my plot, which just has X, and let the color be red. So I'm writing red, or just R would also do. And same thing I have done for my second plot. I've taken a different axis, named it AX2, and to this axis I am giving it the subplot of number 232, which has these same dimensions 15, 10. And then I'm simply doing a plt.show. So both of my plots, it has a title of plot 1, it has a title of plot 2. My x is getting rendered like this and my y is getting rendered like this, and I can analyze both of these things side by side. Subplots need axes, and these axes should be non-negative 3-digit numbers. So you could also have used like 230 or something, 240, not 0 shouldn't be there. So you could have used 241, and then over here you should be using 242. You can see the documentation more clearly to understand these things, these little nuances. But I chose 232 and 231 because I want these plots side by side. If I would change this axis, so if I made my first subplot have 232 number, it will show up first. It will show up later. So my plot 1 is showing up later because it has a greater number 232, and the subplot which has this number 231 is being shown before. So this is just for arrangement of your plots. Has everyone tried this? Guys, please say yes because we might be running out of time. Yeah, so fixed size 15, 10, you can change it to anything of your choice. You can say 10, 10 as well. It depends on the kind of plots that you want to plot. I can have 20, 10 as well here. So you want bigger plots or smaller ones, it all depends on you. It doesn't mean 2 columns and 3 rows, Sudipto. How will you, like, it's a blank sheet for you. How will you divide it into 2 columns and 3 rows? It's not Numpy. It just means that you are giving your subplots a number and then you are arranging them. Okay. If I did 2, 2, 1, let me see. Two rows, 2 columns. And what if I did it 2, 1, 1? Okay, got it, got it. So we are, yeah, so Deepto is right. We are doing the same thing. Let's not get into the nuances right now. So it's covering the whole space and it's saying that I just want 2 subplots over here, and it's dividing that equally. So to this first subplot, it's giving the 50% of the area, and to the second subplot, it's also giving the 50% of area. If, however, I'm writing 3 over here, it's dividing the whole region into 3 parts and giving 33% each to both of them, and letting the 33% of the space remaining vacant. Okay, so Deepto got it? You can try it out on yourself. Yeah, okay. So let's move ahead and go to scatter plots. So scatter plots are really useful, very, very useful, because they establish a relationship between two numerical variables And from these scatter plots, you can see correlation or trend between those two variables. And this is very much used in machine learning concepts like regression, where X and Y are continuous variables, and also used in clustering and detection of outliers. So what you have to do is simply a plt.scatter and pass in your values, which are X, Y. So let me make sure I have my X, Y running. I'll be running this cell for X, Y, and then this plt.scatter X, Y. I forgot plt.show. And indeed, I'm getting this scatter plot. If you want to change the color of your scatters, you can just do color equals to R, or let me do color equals to yellow. So this is how you can customize your scatter plots as well. So over here, there is no pattern that can be seen. Either all of the scatters will be going up, going down, but over here they are all clustered. So this is how you can make out that these two variables are having a relationship or not, a positive one, a negative one, or they are just clustered. So is everyone with me till here? Has everyone tried this? Okay, great. Now you can see the solution notebook and you can try yourself how you can change the marker from a circle to a triangle. So I'm leaving the customizations for you guys to show, and I'll be going over these bar graphs. So there are two bar graphs. The first one is vertical, the second one is horizontal. A bar plot is used when you are comparing several groups. So for example, if you're comparing how much marks a student is scoring in a particular exam, so you have many things. You have different subjects, mathematics, physics, chemistry, etc. And you have the scores on your y-axis. So you're comparing those things on the same chart, and one is categorical. So mathematics, physics is all categorical. The other thing, your marks are all numerical. So for these kind of insights, for these kind of intuition on data, bar graphs are used. So let me just quickly show you how a vertical bar graph is drawn. So it's nothing but if I run this cell which has X, Y, A and B with control enter, and I will just say plt dot bar and will be passing in my X, Y. And then to avoid the extra written material, I will be just doing plt dot show and doing control enter. I'll be getting vertical bar graphs. So my x-axis has 0 to 4 because for x I had np.arrange 5. So y I again had np.random.normalize random numbers from -1 to plus 1.5. And if you would have to draw the same thing using horizontal bar graphs, you could just have used plt dot bar h, which stands for bar graph, which is horizontal, and passed in your x, y, and then done a plt dot show and run this cell using control enter. So you can see horizontal bar graphs over here. We can also draw bar graphs as subplots. So I have an assignment question for you all over here, that draw subplots which is depicting x, the horizontal bar graph for x and y, vertical bar graph for x and y, as well as a horizontal and a vertical bar graph of A and B together as subplots in just one cell. So this is your assignment question for today.